Welcome to episode 157. Man, the number gets bigger and bigger every time. Quarkus Insights. And we got special guest Julien, which I think been here before. Maybe not Julien been before. But they'll talk about Vert.x, and I'll let them introduce themselves in a few seconds. I mean, of course, we have Holly, which is here often, so everyone knows her. Works on Quarkus too.
I'm boring.
And I have a cough. So that's great. No, I just had a little bit of a news news, like things I want people to be aware of, kind of thing. So we just done the 3738 releases, which are the LTS, which is what we had the whole last episode was about. And that means that it's time for changes. Hopefully not big changes. These are all designed to be backwards compatible. But I wanted to mention it because I'm pretty sure we're going to being asked this multiple times. But over the last 3+ years, Quarkus has been always very positive about Reactive, especially in how our backend is implemented. And just part of what Julien's going to talk about is the great stuff that is in Vert.x, that is Reactive toolkit. And we were so happy at cool in 2000, I don't know, like, what's that, like 1920, that we added the word reactive in a lot of our extensions because we wanted to signal to people that, hey, the reactive paradigm is available in Quarkus. But we also have another side approach in Quarkus, is that we don't force reactive on the end user. We want to ensure that you don't have to use reactive, because probably 90% of the cases, it's not the reactive part in your end user app that is gonna be the differentiator. It's more the I/O done by the backend.
And it's not just that we don't force reactive on people, it's that Quarkus works really, really great, even if you're not using reactive.
Yeah, and our default creation, like any Quarkus create app, or have always been a blocking app. Unless, of course, you've chosen something like Hybrid Reactive, which is reactive at its core. Sorry, not at its core, at the interface you have. So, for example, we have like Quarkus Hybrid Reactive is a good name where Hybrid Reactive is used, because you have to use Reactive to use Hybrid Reactive. But Rest Easy Reactive just means that this is Quarkus Rest Easy, which is a reactive core, and you can do blocking or non-blocking just fine. Same with reactive messaging and reactive MySQL client. Rest Easy Reactive and reactive messaging is both places where it's reactive at its core, but as a user, you can just stay with a blocking paradigm. So anyway, we've blocked every time we talk. We always says blocking is fine. We support both equally well. We don't want to. We make sure, big effort, that these two worlds are compatible. But people, in this case, people read the extension and they just ignore all the documentation, all the stuff we talked about, and they assume that reactive is a requirement to use an extension that has reactive in the name. Which I'm not blaming them that that's wrong, but that's just we've decided that this is too big an issue to keep hanging around, because we see again and again people not using the wrong extensions. They use the ones that are not performant, the ones that don't have the latest features, because they use the old ones. So we've done this is what I'm looking here is the ADR architect decision record that we have in the Quarkus repository. That goes through in all the details, and you see here there's a long list of names where we got to rename them to more appropriate ones. So, for example, Quarkus Rest Easy Reactive is going to be used Quarkus Rest instead. Reactive messaging is going to be Quarkus messaging. And we're going to add relocations and all the stuff that matters. So we believe this should be as transparent to everyone, like 90%, 95 maybe. But there are, for example, in 3.7, we did rename the REST client. So if you're using the old Quarkus REST Easy client, the REST client, we recommend you to point to Quarkus REST Easy client. But we hope you not, and most of you are using Quarkus REST Easy Reactive. So anyway, I don't want to bore about details. Just this is coming up in 3.9, so some will be affected by it. But we're doing a CR1 this week where hopefully this will be in there, or at least soon after. Just to give it a context, is we still love Reactive. We are just kind of hiding it in the name because people assume if it says Reactive, they have to use Reactive, which is not the case. So tricky to explain, but I hope that it kind of makes sense. So anyway, that was the news, and now we want to go back to talk about something Reactive or Vert.x because it has advantages. Before I give it to you, Julien, we do insights. We done 157 episodes, and we had to do a refresh. This okay, what do we want to talk about? You want to do some reruns or talk over some new stuff? And we realized, hey, we haven't actually had a Vert.x episode about the basics of what a Vert.x does and what it can be useful for. So that's why we asked Julien to show up here. So Julien, which Julien want to start?
Oh, okay.
The real one, I think.
The real one. Yeah. For the short story, I'm the real Julien. He's the fake Julien Ponge, also known as FGP. Well, for John Paul. Right. It's a joke. Sorry. Hello, everyone. And I'm very happy to be here today and share with you stuff about Vert.x. And I think indeed it was very appropriate to rename all this REST Easy Reactive extension to Reactive when we come to talk about everything Reactive. So Max, tell me, what should we start now, or just do a quick introduction?
Well, quick introduction. You guys drive the show. For everyone who's listening in, just ask questions in the chat, and we will get to it. Like, for example, apparently we messed up the daylight saving time show or something.
We always messed it up.
Yeah, something happened. But
I was quite worried when I was turning up that I was going to be turning up an hour too late.
Actually, somebody on our Discord server also told me that he wasn't seeing anything coming, and I told him, okay, I'm trying to log in, I'm not able to do it. And, so I didn't know if it was what was.
The problem is it's all driven by European time zone. That's what the calendar is in. But I'll mention someone who should be named is the calendar is in US time zone. I think something. Yeah. Anyway. We're here now. It's all good.
Great. So I'm Julien Viet, and I'm French like the other Julien, and I've been doing open source development since 2003, so that's more than 20 years now. And I've been focusing on Vert.x for the past 10 years. I joined Red Hat. I think this year will be 10 years to contribute as a contributor of on Vert.x. And I was very fortunate to be able to contribute with Red Hat on this library. And today we are going to talk about this a bit, and also, what Vert.x does in essence, and what also it does for Quarkus, and how it can be used in Quarkus, especially with the reactive mutiny extensions that we have in Quarkus. All right. Let me share my screen to start. So it's a very basic, as the title says, it is Vert.x 101. So I'm not expecting people to know anything about Vert.x, but I believe what is interesting here is that I can show people basically what is Vert.x, and that actually most of the Quarkus IOs, at least for HTTP and some of the clients, are based on this on Vert.x. 1 second. Well, I don't know if I need to put it in full screen. So what is Vert.x? Vert.x, it's we say it's a toolkit, but also it's a library. And the goal is to build reactive applications. And it was born 14 years ago in open source. And basically, we will see that with Vert.x, you are really much in control of everything. So it's pretty much more like a library than a runtime you will use differently, like Tomcat. And you can use it for a lot of things. And most of the time, we say that it's suitable for microservices, but you can also use it for doing just web applications. It's also used a lot for building HTTP gateways, also access backends. And the main reason is that Vert.x is very efficient for building such kind of use case. So a few words about imperative versus reactive. So Quarkus is able to do both. That you mentioned the non-blocking annotation. In Vert.x, on the other hand, we focus mainly on the reactive part. So what's different is that basically it's a world where when you program something like a server that we'll see with backend interactions, instead of writing code that is blocking, you will use things like futures or mutiny to compose results and provide computation result for the server. So one question is, why are we doing this instead of just doing imperative code all the time? And the main reason is to save resources. Writing such things with reactive gives a lot of, I think, interesting properties. The first one, it's much easier to scale because you scale it in a different manner. And also, you don't focus a lot on tuning thread pools. Instead, let's say if you access the database applications, you will more focus on tuning the size of the database connection pool, which is where actually the real bottleneck is. And if you have something like a thread pool in the story, then it means you also need to configure the thread pool size and a lot of thread things. And it means also you need to use a thread pool size which are the most suitable for the database and the concurrency you want to address in your application.
And so is the picture showing that with the imperative model, you have to use a high number of threads in order to achieve a fairly small amount of concurrency, whereas with the reactive model, you actually only have to use a small number of threads and you still get a high amount of concurrency?
Yes, that's right. Actually, when you don't use reactive, as for now, there is most of the time a one-to-one mapping between a thread and a request and response to the database. So it means when the server accepts a request to serve a request, it will require one thread. And yes, there is also that I didn't mention. Threads are expensive, so you are basically limited to the number of threads you can create. You can create in the JVM and also on your operating system, because by default, when you use platform threads, those are the one of the OS. So, for instance, in this slide, we say it takes 1 megabyte per thread, and this is not a JVM setting. That's an OS setting where you configure that. So it really means it will use a lot of the host resources to achieve this concurrency. And when you use reactive, then just with a few threads, you are able to max those threads out first. So it means you will have a few threads, but they will consume, if that's correct, lead down most of the CPU of your machine. So that's why it's very much more efficient. The way it works is that, yes, in this example, that's an imperative way. We use one thread. It's called worker in this example. And we see that in red, we have the blocked part. So it means that for this thread, we only use the blue parts are where we actually run CPU instructions. And in the red part, the thread is put in a state where it will not do anything until data usually comes to continue the computation. And here, actually, I think this slide is great. But in reality, here we can see that the blue part and the red parts, they are more or less the same size. But in reality, the blue part should just be one. It should not even be visible, I think. And the red part would be most of the life of the thread.
Unless your server happens to be doing something like Bitcoin mining or something on each request.
Yeah, of course. Yeah, that's of course. Here we talk mainly about applications doing IOs, like I mentioned earlier, HTTP gateways. And HTTP gateways, what does it do? It takes data from the input to sometimes computation, but it's very lightweight. It's like computation is what is the backend I need to address, what is the security, and that's it. There are no CPU, EV CPU things. And then it sends those data, it creates to the backend and wait for the backend response. And when the backend response comes, then it will send, well, that's more or less what a lot of applications are doing. And in this case, Vert.x is really good. And the way it works, so I mentioned that we use futures and these kind of things like mutiny. When we do that, we just have one thread. And the idea is that on this thread, we multiplex all the IO operations. So in the blocking imperative world, we use one thread to each, well, basically one thread just cares about one request at a time. And in the reactive part, one thread will deal with many requests at the same time. So it uses the futures all these futures to be able to untangle all the requests. Otherwise, it will not work technically, of course.
And I think these two slides are they're hard to visualize for some people, or including me. But one thing we always see often see is when people compare performance, with Quarkus and Spring or Quarkus or something else that's not reactive at the core, they say, hey, this looks the same. We gave it a bit of load. And then what it turns out is that what happens is it's very easy to make the database or the whatever disk that you're talking to, the one that's the one that's limiting you, right? So then what it turns out is that most applications are just I/O bound. Like they spend most time on I/O, but they don't actually stress the framework because they're not able to give enough load. So, and if you test on your laptop with like 32 cores and whatever is available to you, you have almost unlimited things. But if you're in a cloud native place where there's limited resources, yes, they will on a basic load will be the same. But once you start amp up and you have more load, then suddenly being reactive at the core makes a big difference. And that's where we often see the Quarkus compared to something else difference is when you actually make sure that the resources on where the framework is running is limited. And then you see that Quarkus will survive much longer. It survives much longer because of Vert.x in there. But yeah, anyway, it's a very important slide, these two, because these are basically the reason why are we spending time on making it the core of Quarkus Reactive. It's because we can get control over this stuff to do it.
I do agree. And actually, in reality, in Java, if you use blocking input streams, well, the thing is that in reality, at some point, you will have to do non-blocking stuff with the operating system. So one way is to do it, use that the blocking input stream and output streams, and build your entire stack using blocking paradigm. And in the case of Quarkus and Vert.x, we decided to tackle non-blocking much how to say that at the message level. Like when we receive an HTTP message, we are already non-blocking at this moment. So the reality is that sooner or later you will have to deal with non-blocking stuff, and it happens that in Quarkus, everything at the end of the day, and that's true actually for all frameworks. Even if it's blocking, at some point is going to be non-blocking. Well, because that's the reality of the hardware and that on which we execute our applications. Okay, let's start with a simple demo. So myself, I have two demos. The first one, I want just show to how to do a simple Vert.x HTTP server. So I will not pretend I'm the best coder in the world. So if you want to develop a basic Vert.x HTTP server, you only need a Maven dependency. So it can be Vert.x Web or Vert.x Core. In this example, we already use Vert.x Web, so it's very fine. And what I want to show here is that Vert.x, you create a Vert.x object, and I want to show a bit the library aspect. So here I created a Vert.x instance. It should be closed when it's finished, but in this example, I will not do it. And Vert.x, this object, it handles all the resources that will be used by the application we are going to do. So when we do close Vert.x, we'll close all the servers associated with it, all the clients, and so on. So to create a server, I create an HTTP server like this. I can pass options, but I will not do it. Then I set a request handler, and that's the code where we do this, and then I will just do a request response and hello world. And that's the main server. And when I do this, then I will do listen on HTTP port on my machine. It's going to be localhost 8080. And here, what is interesting is that the result of this will be a future. So, as I said, we deal a lot with futures in this example. So here I can do request.toCompletion_stage get to get the result. Yeah, that's the completable future. And I will add this also. And I think at the end I will just do system in read to avoid exiting the JVM. And that's it. I've done my simple HTTP server. So you can run it like this, well, like just a Java main. Well, I haven't added anything about started. I go like this.
What is that warning? Because I always get it also.
Yeah, this warning, it's a macOS 10, and because actually the Vert.x uses its own DNS resolver, and by default, on macOS it will try to read some of the configuration of the macOS. So the DNS resolver will be aware of the hosts file you have on your machine. So if you tweak your hosts file on macOS, then this allows you reuse the same settings. So it doesn't hurt to not use it, but it's better to have it. And to solve it, you need to add a jar to your application.
Okay.
You can look at the Vert.x core POM file, and you will see that we have it. And that's it. That's my simple server. Hello world. Then I will do what Julien's favorite thing. I will print the thread. I never do that, but he likes to do it. This way we do it, yes, and we print the current thread, and we can see that when we do this request, you see that's the name of the thread that serves the request, and that's Vert.x event loop thread 09, and here it's always the same thread. If I would set a pause and do 1000 concurrent requests, I will always see the same thread that will be printed here. So basically, this shows that a single thread is able to take care of the entire workload on the server.
It looks
That's
like
really
Node.js, right?
Sorry?
It looks like Node.js, right?
Yeah, that's right. So I think Julien is trying to trigger. Oh, yeah, the idea is that here, of course, it's like Node.js. So when we do this, we only use one core of my MacBook Pro. So if I want, I can use more. And to do it, I will need to. It's possible to do it. I will need to put that in a vertical. And well, let's see if I can do it. I will put that in a vertical. Vertical is a deployment thing you have in Vert.x, where we can encapsulate things we deploy. So I will just do this, and in the vertical start, I will. Well, let's not use this one. Let's use this one. It's simpler. I will do this, and I think that should work the same, right?
Yes.
And let's see if it works still. So it still works. And now what I can do is in the deployment options, I can set the number of instances. And if I set 2 instances, then Vert.x will instantiate 2 instances of this vertical, and it will use basically 2 threads. So most of the time that will translate to 2 event loops and 2 CPU. Let's see if it works. Yeah, you see it works. Now when I go here, I connect. The first time I used the event loop thread 0, and now I have another thread. And if I do it, I have the same thread again. And when you have such result, Vert.x is doing naturally load balancing between all the cores on which the vertical has been deployed. All right. So Vert.x, of course, we have seen just simple HTTP server. We do have lots of libraries that we provide with Vert.x to interact not only with HTTP, but also with other backends and other clients. So we support MQTT, Kafka, of course, database clients, and so on. And one of the things we have is that that's very peculiar to Vert.x is that we have our own reactive database clients. And the main reason is that, of course, in Java, a lot of people use JDBC. And but the thing is that JDBC has been developed, has been created 20 years ago when Reactive was not popular. And when you use JDBC, you have to be blocking. There are no choices. So even if your application is written using Vert.x, you have a top-notch non-blocking architecture. And if you access the database using JDBC, then you will reintroduce thread pools in your application. And that's why we created reactive database clients for Vert.x. And those are implemented using Vert.x itself. And therefore, they are fully non-blocking. So we have several of those, and I will show today in the other example the one we use for Postgre. So it's fairly simple. So here again, so in this example, now I'm just going to get rid of this because, well, it's useless. So I've done a main where I start a Postgre container using a test container. And here again, I create a Vert.x instance. I create options to connect to Postgre. So yes, username, all the classic stuff. And then I deploy a vertical, and that's the API vertical. So that's pretty much what we have done just before. But in this example, it's much more complete, and it uses the Vert.x Postgre client to access the database. So this client is very simple. It's basically like JDBC, but it aims to provide, well, that's actually my opinion, a much more simpler API to use than JDBC. It's very, well, but JDBC, I think, was written also a long time ago, so it was not written to be with a lot of usability in mind, I think. Well, so I create my client. So I use a PG builder pool and I configure everything. I say connecting to connect options using Vert.x. And there is another part I'm using in this example is Vert.x Web. So I create a router. What you have seen just before in the previous example was just Vert.x Core. And with Vert.x Core, you have, it's basically just an HTTP server. It doesn't provide things like routing and all these kind of things. And for that, you have an extension called Vert.x Web that is also used in Quarkus. And with Vert.x Web, you are able to do routing and these kind of things. So here I can say I create a router. And then I create, in this router, I mount three APIs. So I do mount /products colon ID and /products. And on these three methods. And each of these methods will use the Postgre client to interact with the database server and then return a response. So let's look, I will not go over all of them. I will just look at /products, for instance. I don't know which one is the best. Which one do you prefer, Max?
Sorry?
You don't care?
You take it.
Well, let's look at list products. So I use the client, I do a query. Well, that's very simple SQL here. And then I do some transformation to transform the results to JSON. So I use here, what is nice is that you are able to use Java collectors to create JSON from the Vert.x rows. And then we just execute, we create a JSON array and we just return the result to Vert.x Web, and Vert.x Web will transform this JSON array into the result we expect.
What should people do if they're using a database for which there isn't a Vert.x client?
That's a good question. So let me tell you rather what we do cover these days. We cover basically the main database. We cover Postgre, MySQL, SQL Server, DB2, and Oracle. So also we do cover a few ones like the Java implementations like like HSQL DB, and the other it's
Derby.
Derby, yeah. Not Derby. The other one, well, that's useful for testing, but usually it's not really used in production. Yeah, so I just run my example here, and well, there is much more logging here because well, that's where it is. And now if I can curl. Well, I have no products by default, so I need to use this. And yeah, so here I did interact with the applications, and I inserted a product. Well, that's simple as that. It triggered this route, I think, for the post. No, it was this one, a post on this one. And now if I do use the other one, then I will see the product we have created. So that's the same. Yeah, so that's the result. The other ones are fairly simple too. So that one is just list products as this one. So it just lists everything. The create product is a bit more complicated because we have to write to the database. So basically, when you have the routing context of Vert.x Web, we take the data, we validate everything is good. And then we do, here we do client.prepared query, we do the insert. We create a tuple from the name and the price, and then we map the result on a row set as a JSON object. So that's why here we are able to return, that's this JSON object will return. And that's pretty much it. It's as simple as that.
So Julien, just if you caught did you mention H2 as support database, or is that?
Yeah, H2. Yeah, well, H2 I think is easy to support because we have an implementation of Vertex SQL clients that use JDBC. So at the end of the day, if the database you want to is not available, you can go to JDBC way to do it, but it will of course be suboptimal.
Yeah, because then you'll go to another thread to do the operations, come back again.
Yes, basically that's it. But for things like for HSQL DB on the other one we mentioned, those are in-memory database, so there are no real latencies when you connect to those databases. So it doesn't matter, right?
And what if you're using something like Cassandra?
Well, we do have a Cassandra client. So we have Cassandra, we have Kafka. Well, I can just have a look on vertex.io, what we do support. So database. So those are the one we developed, the one I mentioned, the Postgre, MySQL, DB2, Oracle, MS SQL client. And then we have also Redis, Mongo, Cassandra, and the one I mentioned, JDBC. And for messaging, we have Kafka, RabbitMQ, MQTT, and MQP client. And then Mail client too, and a lot of other things we do have everything here. And some of them actually are used in Quarkus, like the Redis extension, I think it's used. And Quarkus Reactive Messaging also is based on a few bricks we have here. And like MQTT and MQP are used in Quarkus Reactive Messaging.
And you can find some other drivers in the community, in the Reactiveverse set of community projects. So you can also find other ones.
This is Reactiveverse.io, where we do have some, it's like a very small ecosystem of extensions. We have like the console cluster manager, or this great Elasticsearch client we have.
Cool. I'll stop listing databases now. Just
just before, because I'm a Hibernate guy, right? So you just show me like why would I use Hibernate anymore? I just want to remind people that what Julien was showing is, let's call low-level data mapping, right? Like it's literally just raw data access, which for some cases are perfectly fine. But then, of course, when you move up a bit, you have to deal with transactions or state, because you did manipulations and graphs. Then things become more complicated, and I think that's where the difference between Vertex and Quarkus is that we start adding a little layer on top to make it a bit more prettier. But I guess that's what Julien's gonna.
Yes, I think actually here also we could talk briefly about Hibernate Reactive that's built entirely on Vertex SQL clients.
Yes.
Those, they can be used in Quarkus or just in Vertex as well. I should have mentioned them, but I didn't. Sorry.
We've got.
Oh, God, yes.
Yeah, we've got one of the big questions that I think a lot of people are asking now, which is, does Loom make all of this pointless? And why are you even here when there is Loom? So what about virtual threads? Do they mean that for Vertex and Quarkus, do they make reactive unnecessary?
Yeah, that's a great question, I think. Yeah, my opinion here is that today it's still very early to know how we are going to use Loom and virtual threads. It's like when Java NIO was created, I remember that it took a few years to be able to use them and discover how we can use them efficiently. The thing I can say is that currently with Vertex, we have an async await extensions for Java 21 that you can use with Vertex. And for Quarkus, there is this @run on virtual threads that does something similar. Actually, my opinion here is that Vertex is not coupled to, at all costs, to reactive and non-blocking. The reason Vertex use futures and unblocking is that when we started the project, we wanted to be able to give people a very easy way to the simplest way to develop non-blocking applications, because it's not easy to develop non-blocking applications. And at this moment of time, there was no choice. If you want to do something highly concurrent, very efficient, you have to use non-blocking. And now with virtual threads, maybe Vert.x will continue to exist, I hope. And it will keep the same spirit and simplicity. And if you can use only virtual threads, then we will do it. We are not married forever to this future / non-blocking / mutiny programming model.
Yeah, and I think we actually have an episode I just posted in the chat. Oh, that was a very bad link. I hope it works. The Quarkus is episode 153. We go in depth about these things, but people have to remember. Yeah, horrible you are.
Yeah, it's really beautiful.
Yeah, people can check that out.
At least there is no token or anything.
Just having it. No. But the thing is, as Julien said, even Quarkus are tied to a reactive programmer model. But it's just that so I see the way I explain to people is that it's like we have 2.5 models. Before we had 2 models, like the imperative and traditional blocking and the reactive one. But with virtual threads, it's like a hybrid or 2 in between. But the thing is that virtual threads in its current form definitely is nicer to, like, as a, let's call it a normal, let's say a regular programmer. It's nicer to use virtual threads because it's just blocking most of the time, right? But the concurrency stuff is still the same. Like just because you can run 1,000 threads doesn't make it easier. Like, it's still hard to do concurrent programming. And there's just some approaches that are just nicer expressed in a reactive model. But even more, the difference, there's a practical limitation in virtual threads right now is, for example, in Java 21, if you use the synchronized block in some code, which you do a lot of libraries, then you have a performance issue, which they fixed in Java 22, I think, or 23. But even then, Loom or virtual threads does not allow frameworks like Quarkus or Mutiny or Vert.x or others to participate in how things get scheduled. So therefore, things like back pressure and a lot like really tuning things, it's just not possible with virtual threads. And that's why we still are using reactive in the core. And also, if you want to move to virtual threads, we have to drop support for Java 17. So that's a mix of practical reasons. So to answer the question, virtual threads is definitely, I think it's going to be the more, like, the broader available for people to use. But in Quarkus, it's probably going to be I hope, a smooth transition where you can choose which one you want to do. At least that's the goal we have in the Quarkus 3x. And in the future, yeah, anything can happen. It's not like we're tied to what's there. But as things are looking, I think virtual threads and reactive is still going to be around for a number of years.
I think also the answer also lies in the fact that if you develop a simple linear flow, like you have complex interactions with a single database and you do all these round trips, then virtual thread is great because you can simplify your code and it's very linear. But when you start to have interactions with multiple backends simultaneously, then even with virtual thread, it starts to become complex, and you need to have a way to coordinate all of things. They try to do it with structured concurrency. But if you look at structured concurrency, it's more or less the same way you will use multiple features to combine them and do that. So
and structured concurrency is not very what we call framework workable. Like it becomes hard to abstract things. So we want to get to Julien, but I just saw there's a question here. Someone, I can't add the questions to the screen because the username is a bit inappropriate. He's saying like how you find adoption within the 550 set. It's hard to move from documentation everywhere Spring Boot. I'm the only one in my very last company to work with Quarkus. So I can't say because these are like we're not allowed to reference them. But I just took a look at the 1450 set, and I recognize multiple multiple companies that either we know from the community or we even know that are working with Red Hat as a Quarkus customer. So they're there, but yeah, if that helps you. But for sure, Spring and other frameworks they had like 10, 15 years before us. But be the good one and show the way for people is good. And as always, if you go on Sula, we can help you with like pointers and stuff. But yeah, they are there. The users are there. I think, did we get on the top of? Yeah.
We've got a couple of other questions as well.
Yeah, but they're all about Mutiny, right?
Yeah.
So Julien, you have 10 minutes.
Perfect. So I will just share my one screen. So I won't spend lots of time on slides. Can you see me? Yeah. It's okay. So just want to reemphasize that Vert.x is in Quarkus because it's meant to be resource efficient if you want to build services that can deal with lots of concurrent connections and end-to-end reactive programming model. So we have Vert.x at the core, but of course, when you're using Quarkus, you typically don't really deal with the Vert.x directly. You're probably going to use REST-easy, you're going to use Hibernate Reactive if you want reactive database access for some kind of applications. You will be programming with Mutiny to compose asynchronous operations. But still, if you want to, you can have direct access to Vert.x. So that's what I'm going to show you in code. So I have here a very simple class, which is application scoped, right? And I can inject the Vert.x context. And that's the Vert.x core, but I can use also the Mutiny bindings if I want to. Well, actually, I'm using the Mutiny binding. So that's the Vert.x context that Julien showed you before, but with extra Mutiny API. So when you have a feature, you return a uni and stuff like that, just to make it use Mutiny. And that's really your regular Vert.x. So you can set a timer, you can have periodic tasks, you can perform, if you want to, DNS queries, you can do all that stuff. You can even create a TCP server if you want to. So Julien didn't show you, but he showed you how to create an HTTP server, but you can create a TCP server if you want to, like this one. And basically it's going to just repeat and echo whatever you send it. And listen on port 3000. So if I just start my Quarkus application with Quarkus there that everybody knows, let me just show you what happens. So in the logs, you can see that, what can you see? So I have my server, I can just say netcat like that. And I see that I have my new connection being created and I can say hello, and it's going to repeat, etc. So I'm doing, Vert.x, but in my Quarkus shell, if you will. The only thing that I have to say is when you do stuff like that and you create servers using Vert.x in Quarkus, you're not going to have the dev mode reload that you have with HTTP, for example, or for the Kafka connectors and stuff, because that's managed by Quarkus through the extensions. But if you do raw Vert.x, like bare bones Vert.x, of course, you don't have that nice dev mode thing. But still, it's interesting because it shows you have Vert.x if you want to do some very low-level things or very custom things with some network protocols where you don't have a driver, maybe, or maybe think of IoT things sometimes, stuff like that. If you remember what Julien showed you, we can do the same kind of Vert.x API talking to Postgres to your database to expose products and stuff. But you can do it in Quarkus, and this is this is going to be a little more managed. So we can do two things. We can use we can inject the PG pool instance. Like before that, Julien created the PG pool reference by himself. Like he would say, this is my the URL to connect to my Postgres database, the port number, the username, the password, etc. But this can be managed by Quarkus. And the proof is that if you go through the logs, you see that we have a dev service which is running for Postgres. So I have my Postgres container working because I have because I'm using the PG pool and I'm using the Maven coordinates to say I want to use the Vert.x Postgres driver, which is always nice. And basically, yeah, it's going to be given to me with the configuration from Quarkus. So I don't have to mess with the rest. I can also, of course, use startup events, stuff like that, to prepare my database if I want to. So I can create my table and fill with a few items, and then I can access the router. So Julien showed you how to use the Vert.x router from Vert.x. Like he would create that router by himself and then say get and post and stuff like that. If you want to, you can use a CGI observe annotation to say, give me the router that, say, REST is going to use and others. So if I want a router and expose some routes through a router or not REST or something like that, it's something you can do. So you get your router and you can do pretty much anything you want. And the nice thing is, in this case, and I hope I'm not mistaken, but this should be the HTTP pool that's managed by Quarkus. So you should be able to get reload. That's in dev mode that works properly. So you can do it like that, get the router and then declare your route manually. Or you can use some annotation goodness if you want to. Like you can say @route and say which path it is, which method it is, etc. So you can say which HTTP method should be used for that route, etc. So it gives you a little more concise way to declare custom routes if you want to. And it's also something you can do if you write your own extension. You can access the router and plug some new routes in your Quarkus application. And then, yeah, the direct translation of whatever Julien was doing before is just that. Like, if I want to list all the products and do select star from product, you just declare your route like that to say it's a get method on /products, and then so that's really your Vert.x route. And then you do your query just like before, except that now you have the mutiny binding. So if you want to transform the response, you do on item transform, and then you collect all the response into a JSON array. And this is why you have a uni of JSON array, because you produce an asynchronous response, which is a JSON array.
We got a question, son. Like you said, this was different between what Julien was showing with Vert.x or where you, Julien, was showing about Mutiny. We have George, like, any plans to use Mutiny in the Vert.x core API, or is it better to have them separated to avoid breaking? Like, why are they different? Why are they not the same? Why should they be the same? Yeah.
Well, I would say I don't want to speak for the other Julien, but I think in Vert.x it's nice to have those future APIs for one-shot operations. That's really tied to a Vert.x core, and then from here you can generate bindings for other reactive programming libraries or Kotlin coroutines if you want to. So this is why for a long time we had Eric's Java support in Vert.x. We've had Kotlin coroutine support using what's in Vert.x core and generating some bindings. The mutiny bindings that you can use in Quarkus, they are generated from the core asynchronous APIs from Vert.x, etc., etc. So basically gives you a wider span of possibilities to have some asynchronous programming libraries, or non-asynchronous actually, because if you have, say, Kotlin coroutines, that's a pretty good example. You're not exactly doing asynchronous programming when you write with coroutines. You're doing something that looks like in plain imperative programming, although underneath it's going to be something different. But
Yeah, that's one of the things that people like. I know that it took me a while to realize is that you have like Mutiny, you have Vert.x, you have Google, Kotlin coroutines, you have Spring Reactor, you have whatever next Reactive framework. They all try and do the same thing, but they are different, right? And that's where stuff like Mutiny and Mutiny Zero makes, at least try and makes a what do you call, like, everyone coexist in a happy family.
Well, actually, if you're using virtual threads, for example, with Loom, you can use the Mutiny bindings because, you can do something like await at most 5 seconds, something like that. And this is Loom friendly. So you can use the efficient reactive drivers for whatever you want and still, write your business logic in using Loom and something that looks like it's imperative. So it's also something to think about.
Yeah. So maybe there's where was it? There was one that says, where is it? If given the opportunity to choose between Vert.x and Mutiny, which one should I select?
Obviously both, because there are two different things. Like Vert.x is the network toolkit. Really, it's what allows you to make asynchronous I/O, and then Mutiny is what you will use as a user API to compose those asynchronous operations. To say, when I have a buffer coming from HTTP request, what should I do next? When I have a failure, what should I do next, etc. So they're not. It's not one or the other. It's the two together that you should be using.
Yeah. Exactly. Good. Very good answer.
What else? I think we're probably going to run out of time, but again, we'll share with you the code. But it's really the key thing is Quarkus is based on Vert.x, and you have Vert.x inside Quarkus if you want to, and that's really fine too. If you had those kind of success, and if you for some reason you want routes rather than using REST-easy, it's also available like that, just like in plain Vert.x, just like what Julien did before. And you get all the niceties, the nice things from Quarkus, like the dev survey, stuff like that. Although you're just doing something which is more Vert.x code than proper Quarkus code, if you will. And I think that's it, because then what we had in slide is more like, again, just that's a nice picture from Clément, just to show you that you had that reactive core, and then the business logic you write on the outer side is, you can use worker threads if you want to. That's really fine, or visual threads, or non-blocking IO threads, whatever you want. And if you're of course interested in how to use Vert.x in Quarkus, there are the Vert.x documentation, of course, a bunch of good guys on the Quarkus website to show you how to use various things like Vert.x, or what's the architecture of Quarkus, how is it done, how do I use the reactive client, etc. And of course, shameless plug, if you really want to learn Vert.x, there's a very good book written by a great author, I think.
I mean, even if you don't want to learn Vert.x, you should buy the book just so that you can make a more informed choice.
Yeah, I didn't dare to say it, but you're right.
Yeah. No, can you go, like, the slides with the 3 circles? Can you go back to that one?
This one? Oh, this one.
Yeah. Right. Because that's the key thing, is like these 3 things are actually playing well together. And yes, Quarkus, like majority of, I don't want to talk in absolutes, but most people will, the stuff that we have in Quarkus are just the common things wrapped up nicely, right? So, you want to have a REST endpoint, or you want to talk to Kafka, you want to do X, Y, Z, right? And it just takes care of a little bit extra things on top. But if you want to do like really custom stuff, or thinks that the stuff that we do in Quarkus is just too much overhead, which it's not, but if you are, you can always go to Vert.x and do more interesting stuff, and play with things. And it's not Quark's not trying to put vertex in the corner and be like hide it. It is part of the API that you can use, but don't be surprised if you never get to use it, and also don't get surprised if you find out, oh, I use this all the time. It's it very much depends. Yeah, we got a few more questions. Holly, can you spot them? My screen is being a bit weird now.
Yep. So we've got one sort of into the details of when you do. I don't know if you want to bring up the code again, actually, Julien. When you do
Sure.
on item transform, should you dispatch the Lambda code building the JSON array to a worker thread, or is it okay to just leave it in the event loop?
Sure. So it's really this piece of code, which is a synchronous transformation of something. So basically, when you have an item, you can transform like on the CPU, or you can say transform to union, transform to multi if you are doing further asynchronous operations, IO, I mean, further IO operations. That's something which is very, I mean, there is no IO involved in this, and it's going to run very, very quickly. So just as, you know, if you remember that picture where Julien said in the beginning that the CPU-bound workload stuff you do tend to be very small, I can guarantee you that this thing is going to be very small. So you can run that on the event loop thread. It's something you should definitely do because you're not going to block for a long time at all. It's going to be very fast.
Yeah, that's basically the general rule is, well, there's two. What's it like? The two rules, and they are like, one is you should never block the event loop.
Yeah.
But also you should not spend time switching over to another thread and back again, because you can do a lot in that time it takes.
Yeah, basically blocking is really when you do IO, or if you really, really do something which is like a heavy computation. But that in that case, yes, you should have said that to a worker thread and make sure you don't block the event loop. But anything else like those very trivial things, just don't bother. Just do it on the event loop until you have a proper performance.
And if for some reason you have like some complex algorithm which are gonna like, I don't know, communicate with something else, then that's probably split up better in small, like separate handlings rather than one big block of code. So yeah. So in general, anything on CPU, just keep doing it unless it's like it's literally a background job rather than it's a thing.
Unless you get a warning in the console that's
you're
blocking.
Good example. So I think Vert.x does that automatically too, right?
Yeah,
it does.
So Vert.x and Quarkus will spit out saying, "Hey, this is taking longer than usual, or longer." I forgot the time. It's like 10 milliseconds, like a few seconds or something. Because you shouldn't be blocking for long. And that's actually a good example of something we can't do with virtual threads. And that is the virtual threads, we don't have a way to detect that. So when you actually do use virtual threads, we are not able to give you a warning about that these are taking longer. I think maybe did Clement find a weird way of doing it? Maybe, but in default we can't for that. And I see Jürgen makes you happy. He just bought the book.
Yeah. Many thanks. Many thanks.
Yeah, and that was a really good question about the event loop. Thank you. And we've got another one about whether Vert.x provides support for streaming request and responses just as gRPC does.
Yes, of course.
Yes.
In the example, you have shown a way to just send one buffer, but you have a full-fledged request and response streaming with back pressure.
Yeah, and in the mutiny bindings, when you have a read stream from Vert.x, it gets converted to a multi with support for back pressure. So it becomes a reactive stream.
Automatically. And if you use mutiny, if you return a multi in Quarkus, then Quarkus, the IO thread, while the IO subscribing to this multi, you return from your code will also honor back pressure on the multi.
So it all fits nicely together. Magic.
Yes, it's all well integrated.
Nice.
Awesome. Cool. I think we got all the questions.
Yeah, I think so. Which is as well because we've been going for a while.
Awesome. But Julien, thank you for for being here. And yeah, go buy the books.
Make him rich.
So yeah, no, cool. Well, let's end it there. And thank you. And see you guys next time.
Thank you, Max.